So we have talked about kinetic energy, and now it is time to discuss potential energy. Okay, and especially gravitational potential energy. All right, so firstly, what is potential energy? Okay, so potential energy is the stored energy an object has due to its position. For example, for gravitational potential energy, so I'm going to abbreviate this as GPE. Okay. This is the stored energy an object has due to its position relative to the Earth. Okay? And something really important I want you to remember is if an object is above ground, that is, it has height, then it has gravitational potential energy. Okay, again, GPE. Very good. Now, let's think about this for a moment. Okay, let's say that there is. Okay, let's say that this is your foot. Okay, and there is an object. Okay, there's a little object that is 1 inch. Let's say it's 1 inch above ground. Okay, if it were to fall onto your foot, would it be would it do as much damage as if it fell from, let's say, okay, let's say it fell from 6 feet. Hmm? Which one would we say would do more damage? Probably this one. Okay, so the one that's 6 feet above ground will have more potential to do damage. Okay, so the higher an object is above ground, the more gravitational potential energy it has. Okay, let's say that let's say that two objects are going to be falling from the same distance. Okay, let's say I have this here a tennis ball, hmm, tennis ball, and then let's say here I have a bowling ball. Okay, now I want you to think about this. If these were both to fall onto something, which one do we think would do more damage? Probably this one, right? The bowling ball would do more damage. Okay, so then we can say that heavier the heavier the object has, that is, the more mass it has, the more gravitational potential energy it has. Okay, very good. Now we are going to take a quick look at the formula for calculating the exact amount of gravitational potential energy that an atom has. So the formula for this is GPE, stands for gravitational potential energy, is equal to mgh. Okay, three simple letters. I would like you to remember this and memorize this. Okay, but let's explore this formula a little bit further. Okay, so m is equal to mass. Okay, and this is going to be in units of kilograms. Okay? This is going to be in kilograms. Okay, g is acceleration due to gravity, but we're just going to call it gravity. Okay? And it's very important to note that on Earth, g equals 9.8 meters per second squared. Very important to remember. For a lot of our problems, we will round up to 10 meters per second squared. Okay, but I want you to remember g is equal to 9.8 meters per second squared on Earth. Okay, so if it's not specified, if it's on Earth, or if the amount is not specified, I want you to use 9.8 meters per second squared for g. Okay, now what about h? H is going to be height. Okay, height. I don't know why it keeps making that late. H is for height, and this is going to be in meters. All right, very good. And again, if we are writing letters next to each other, okay, the multiplication is implied. Very good. Now let's apply this formula on a few problems. Okay, let's say we have an object whose mass is, let's say, 2 kilograms. okay, and it has a height, so it's above ground, let's say 5 meters, okay? And let's say that I want you to round g to 10 meters per second squared. Okay? What is the gravitational potential energy? So just like we did for kinetic energy, our first step in calculating this is first to write the formula for gravitational potential energy, which is 3 letters, N, G, H. Okay. So now let's plug in our values for each of these. So N, what is M equal to? It's 2 kilograms. So I'm going to write, instead of M, I'm going to write 2 kilograms. Okay. Then I'm going to use pink for G. So for G, I say to round that up to 10 meters per second squared. Okay. And let's use green for H. Okay. So we said H is equal to 5 meters. So in place of writing H, I'm going to write 5 meters. Okay. Again, these are all multiplied. Let me bring down that GPE is equal to this. All right. So since this is all multiplication, we don't have to worry about our PEMDAS. But let's see. So first, what is 2 kilograms times 10 meters per second squared? So what is 2 times 10? That is 20. Okay. I'm going to bring down my kg. Okay. And then I'm going to bring down my meters per second squared. I'm going to bring down my meters per second squared. Okay. Untouched. And then I have not touched my 5 meters just yet. Okay. So now GPE, okay, is equal to 20 kilograms meters per second squared times 5 meters. All right. So let's bring this down. What is 20 times 5? So what is 20 times 5? That is 100. Okay. And then we're going to bring down our kgs. Okay. We have our meters per second squared. And we also have another meters from the height. Of course, we have two m's here. We can make those m squared. But for our intents and purposes, I'm going to keep it as it is. So if you have your final answer as this, 100 kilograms times meter squared per second squared times meters, that is completely fine. Okay? But if you remember, the unit for energy is again joules. So the unit for energy is joules, okay, or J. So it would be much better if you wrote, okay, instead of all of these units, you can just say that the gravitational potential energy is 100 joules. Very good.